The Army Rocket and Guided Missile Agency was given command of the project, and Bell Labs was given full system responsibility. Western Electric and BTL, as prime contractors, directed the efforts of major subcontractors and hundreds of additional suppliers. The Army required that the development be conducted in such a way that whenever authorization was given, the system could be deployed within 5 years. Work proceeded rapidly on the Zeus program. Many technological advances were required in radars, data processing, and the missile. The system required several radars, each in its own way to have unprecedented capabilities. Innovative focusing lenses, reflectors, huge bearings. All kinds of parts, large and small, had to be fabricated to precise specifications. The transistor, a Bell Labs invention, was a major contribution to data processing. A special transistor developed for Zeus computers made possible significant advances in overall reliability. A telephone manufacturing technique, wire-wrapped connections instead of soldered joints, also improved computer reliability. Use of large capacity, solid-state computer hardware arranged in modular configuration facilitated manufacture, simplified maintenance, and minimized costs. Douglas Aircraft was responsible for the long-range Zeus missile. The first stage motor produced almost 500,000 pounds of thrust. The most powerful solid propellant motor yet developed. Fins on the jet head steered the missile within the atmosphere, while exhaust gases expelled through the fins steered the jet head outside the atmosphere. To prove in hardware and system designs and to provide the means for gathering data on re-entry phenomena, Nike Zeus equipment was installed at test sites from Ascension Island in the Atlantic to the Kwajalein Atoll in the Pacific. In 1959, Kwajalein was selected as the final test site because it would allow full Zeus system tests against ICBMs launched from California starting in 1962. It already had a concrete landing strip and a fine harbor, which were ideal for the vast amount of equipment that had to be shipped in order to assemble a fully integrated Zeus system. Even so, much had to be done to transform a naval station into a proving ground for the world's most sophisticated ABM technology. The first major Zeus system tests would be at White Sands Missile Range, New Mexico, because of the unique launch-to-impact instrumentation here and the ability to recover missile parts after firing. In 1958, the Army Corps of Engineers contracted for and supervised site construction, preparing the way for the installation and proving in of Zeus components. The system's acquisition radar consisted of separate transmitting and receiving equipment. The receiving antenna used a Lüneburg lens constructed of thousands of polyfoam blocks containing tiny metal slivers. Return signals were focused by the lens on the rotating arms containing receiver equipment to acquire and track targets in 3 dimensions. Its unique feature was its ability to continuously track targets while simultaneously searching 100 million cubic miles of space at a high data rate. Standing some 8 stories high, the receiving antenna rotated in synchronism with the transmitting antenna. Installation of the target track and missile track radars would soon follow. The first target track radar was installed at Bell Labs Whippany to provide a local prototype for proving purposes. In 1961, the Whippany model, encased in its inflatable radome, tracked the Echo satellite at distances up to 2,300 miles, and later successfully received a signal bounced off the moon. Concurrently with these activities, the Ascension Island TTR was installed, and tracking tests began early in 1961.